Hi, my name is Miss Steinges, and I created this video because I wanted to prove to you that you will actually use some of the math that you're learning in class. So I recorded a couple of my friends using the math that you're learning in their professional careers. Enjoy.
My name is Tina Kruger. I'm an architectural designer here at Ryan Companies. We're a design-build contractor, and I get to work on a lot of different types of buildings. The building. And what we do is calculate what the building's square footage is. And the parking requirements are directly related to how much square footage we have in the building. So the more building you have, the more parking you have. And then there's always a percentage of handicap spots that are required for how many regular parking spots you have. And then to figure out how much square footage goes into the building, we have to take a look at the programming. For example, this is a floor plan showing open office area and loading dock areas, building lobby areas, restroom areas. So we need to actually calculate how much space this is to figure out what the size of the building is going to be. This is my sketch paper, and I just leave it on the side of my desk because I take notes all the time and I do little math problems. So every one of these pages has a bunch of little, mostly algebra problems on it.
I'm Dan. I'm a sheetrocker. People hire me to install sheetrock on the walls and ceilings of their new home. And they ask me to give them an estimate on how much that might cost. So I receive the plan from the contractor or the homeowner, and I have to measure the plan for how many sheets of sheetrock I'm going to need. The plan is on a 1/4-inch scale, so I'll use a ruler or a measuring wheel. And for instance, this wall measures 4 1/4, so that's 17 feet long. It's 1/4 inch for each foot of wall. So I'll measure the length of the house times the width of the house, and that will give me the ceiling square footage. And then I'll measure all the outside walls, all the perimeter walls, and multiply those by the height of the ceiling. And that gives me the square footage that I need for the walls. And then I'll measure the interior partitions, the walls in between the rooms, and I'll multiply those by the height of the ceiling times 2, which will give me both sides of the interior partitions that I need to sheetrock. I take the total of all that and I divide that by 48 because there's 48 square feet in a sheet of rock. And that tells me how many sheets of rock I'm going to need to install in this house to cover all the walls and ceilings. Then I take the sheet count and I multiply that, say, by $100, and that will give me the cost of how much it's going to cost me to buy the sheetrock, haul it over there, and install it in the house with the labor and the screws and the glue and stuff that we need to install it. That's the total of my estimate. My installers use fractions to cut and fit the sheetrock that they need for the wall. The measuring guy will yell a measurement to the cutter. I need one that's 32.5 by 47.6, and what that is 32 5/8 by 47 3/4.
Hi, I'm Troy. I'm an actor in New York, and when I get paid, I have to give my agent 10% of the money that I make.
My name's Nolan. I'm a construction worker. Right now I'm working on a parking ramp for St. Thomas University in St. Paul, Minnesota. We know that right here, this note says it's a 5-inch concrete slab. So it's 5 inches thick. It's going to be 60 feet wide. And there's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9 bays. And a bay is just a term for an area between 2 columns. So I say 9 bays. And each one of those bays is 22 feet across. So you go 9 times 22 feet is 198 feet times 60 feet wide is 11,880 square feet. And so we know that we've got a 5-inch thick slab and we need to convert that to feet. So we know that there is, for every 1 foot, we know there's 12 inches. So the inches cancel out and we've got 5 divided by 12, 0.417. We'll round it to 0.417 feet. Okay. So now we'll take our 11,880 square feet times the thickness, 5 inches. We've got 4,950 cubic feet. But you can't buy concrete in cubic feet, you buy concrete in cubic yards, so we need to convert this to cubic yards. So we'll take our 4,950 cubic feet, and we know for every cubic yard there are 27 cubic feet. So take our number, divide by 27. 183.3. Sorry, those are supposed to be cubed. 183 yards, cubic yards. We'll take this number and we'll round it up. Usually give ourselves a little bit of room for error, so we might order
Alright, that's it. I hope you enjoyed the video and learned a little bit. Thanks for your attention.